students. So in this lecture I'm going to continue with the same topic, that is photodiode. In the last lectures I've discussed about what is photodiode, what are the operational modes of photodiode, the construction of photodiode and working of photodiode. So in this lecture, depending upon the working of photodiode, I'll discuss the VI characteristic curve of photodiode. So this is the VI characteristic curve. So we know that photodiode is always operated in reverse biased mode. The VI characteristic is shown here, in which this reverse biased voltages are plotted horizontally. That is, this is the reverse biased voltage and it is in volts, and the reverse current is plotted along this y axis. The reverse current is plotted along the y-axis and it is in microamperes. Now, as can be seen from the figure, the reverse current is almost independent from reverse voltage. So, consider this graph. As you can see, this is the reverse current graph versus voltage. So, even if we keep on increasing the voltage, there is very little or negligible change in the current. Similarly, for other graph also, if we keep on increasing the voltage, there is no or negligible change in the current. So we can say that the reverse current is almost independent from the reverse voltage. Now when the illumination is zero, then the reverse current is approximately zero. Illumination means the light falling on the depletion region of the PN junction diode or photodiode is zero. Then the reverse current is approximately zero. You can say the reverse current, it is approximately zero. That is, a very small amount of current is present, and this current is called dark current. So this current is called dark current. Here I have written also, it is dark current. Now as we increase the illumination, if we keep on increasing the illumination, so this is showing 2500, 2000 lux, 1500. So this is the luminous intensity, luminous flux intensity. So if we keep on increasing the illumination at the PN junction, at the depletion region of the photodiode, that is on increasing the intensity of light, the reverse current also increases linearly. So as you can see, initially there was no illumination, the reverse current was this. Now if we increase the illumination to 1000 lux, then the reverse current is this. Now on further increasing the luminous intensity, the reverse current is increasing linearly. So we can see that the illumination at illumination 1000 lux, the reverse current is 100 microamperes. The reverse current is 100 microamperes. At illumination 1500 lux, the reverse current is 200 microamperes. And at illumination of 2000 lux, the reverse current is 300 microamperes, etc., which shows that reverse current is increasing linearly with the luminous intensity. So this is the graph showing the reverse current with respect to illuminance. So as the luminous intensity, or as we keep on increasing the illumination, the reverse current is increasing linearly. So this was about the VI characteristics of photodiode. Now moving on to the advantages of photodiode. So as you can see, it shows, as I've already told you, the photodiode shows a quick response when exposed to light. The second advantage is it offers high operational speed. That is, the response time is less. Obviously it will show a high operational speed. Then it provides a linear response, as I've told you from this graph, that with the increasing luminous intensity, or with the increase in the intensity of light falling on the depletion region of photodiode, the current, so the reverse saturation current also increases linearly. And the last advantage, it is a low cost device. Now, moving on to the disadvantages of photodiode, it is a temperature dependent device and it ensures poor temperature stability. Obviously, if the photodiode gets the energy from the temperature, then also electron hole pairs will get generated and the reverse saturation current will increase. So, this photodiode is temperature dependent or temperature sensitive device and it shows poor temperature stability. Now, the next disadvantage is when low illumination is provided, then amplification is necessary. Obviously, when there is very less illumination or the intensity of light falling on the depletion region of photodiode is very less, then the current so generated is also very less. So, we need an amplification of that current. We need to amplify that current. Now, this was about the advantages and disadvantages of photodiode. Now, moving on to the applications of photodiode. So, photodiode majorly finds its use in counters and switching circuits. So, how? That is when number of items, you have seen a conveyor belt. So, when number of items go through a conveyor belt, this can be easily counted by using photodiode. So here a light source is attached on one side of the conveyor belt and a photodiode is attached on the opposite side of the belt. Now the light source and the photodiode are fitted in such a way that the light comes directly to the photodiode. Now as the light falls on the photodiode, there will be a reverse saturation current in the circuit. Now we connect the photodiode with the counter circuit. Whenever the light beam breaks, the counter gets one increment. So when one item passes the light beam, it breaks the light beam, that is it stops the light beam reaching the photodiode and the counter counts the item or counter gets incremented. So this is how photodiode is used in counters and switching circuits. Second is photodiodes are extensively used in an optical communication system. Third application is logical circuits, that is it is also used in logical circuits and encoders. And the fourth application is it is widely used in burglar alarm systems. In such alarm systems, until exposure to radiation is not interrupted, the reverse saturation current will flow. That is, in such alarm systems, what happens until exposure to radiation, until the photodiode gets the exposure to radiation, that it is not interrupted, then the reverse current will keep on flowing, and as the light energy fails to fall on the device, it sounds the alarm. So this is how photodiode is used in the burglar alarms also. So this was all about photodiode. I am ending this class here. Thank you.